In order to predict the electron pair geometry and molecular shape of SCl2, draw a Lewis diagram to help visualize how the atoms are bonded and if any lone pairs are present. Before drawing a Lewis diagram, refer to the periodic table of elements to find the number of valence electrons in each atom. The total number of valence electrons in this molecule is 20. 6 electrons from sulfur and 7 electrons from each chlorine atom. After drawing the Lewis diagram, count the number of valence electrons in the molecule and compare that value to the calculated number of valence electrons to confirm the correct diagram was drawn. In this molecule, there are 4 electron groups, 2 shared electron groups between sulfur and chlorine, and 2 lone pairs on sulfur. Therefore, the electron pair geometry is tetrahedral. Since there are only 2 atoms bonded to sulfur, the molecular shape is bent. The electron groups being negatively charged repel each other and are positioned at maximum distances away from the other groups. The 2 lone electron pairs on sulfur exert greater repulsion towards the other electron groups, resulting in a bond angle between the chlorine atoms to be 100 degrees rather than 109.5 degrees. When depicting a molecule with 2 lone pairs, place the 2 lone pairs next to each other in the Lewis diagram because this will create the correct angle. This is a ball and stick model of SCl2. The electron pair geometry is tetrahedral and the molecular shape is bent with a 100-degree bond angle. Although the 2 lone pairs present on sulfur is not shown in this model, they influence the shape of this molecule. Now, let's figure out which type of bond is present in SCl2. Refer to the periodic table of elements to find the electronegativity value for each atom. Chlorine is more electronegative than sulfur because of the periodic table trend that electronegativity increases from left to right across the period. To confirm this, the electronegativity value of sulfur is 2.5 and chlorine is 3.0. Chlorine will have a greater attraction for the electrons in the sulfur to chlorine bond because it is more electronegative than sulfur. This is represented by chlorine having a partial negative and sulfur having a partial positive. Finding the electronegativity difference between chlorine and sulfur will assist in determining which type of bond is present. When referring back to the possible bond types, this molecule has polar covalent bonds. Although there are polar bonds present, the polarity of this molecule cannot be assumed as polar. To predict molecular polarity, begin by drawing dipole moments for each bond. Dipole moments show the direction of the greatest electron density. Start the arrow at the positive end and draw the point of the arrow towards the negative end of the bond. To determine if this molecule has a net dipole, add the vectors together. Begin by drawing the first vector, paying attention to the length and the orientation. Then, continue by drawing the second vector, starting from the head of the previous vector. Continue to draw vectors until all are used. If the head of the final vector is located at the tail of the first, then no net dipole moment exists and the molecule is considered nonpolar. Since the dipole moments do not cancel, SCl2 has a net dipole and is considered to be a polar molecule.